Unfortunately, it's impossible to have a perfect study. Probability samples and observational studies certainly help, but sampling in practice often has some difficulties that this random sample just can't solve. Using a randomized comparative experiment is a great way to approach an experiment, but there's still going to be issues with experimenting that you can't. But there's still going to be issues in experimenting that you just can't solve with this randomized comparative experiment. The logic of our randomized comparative experiment assumes that all the subjects are treated alike except for the treatments that the experiment is designed to compare. Any additional unequal treatments can cause bias. So you want to make sure that you are doing this idea of equal treatment. So an example at looking at a new breakfast cereal to determine if it provides good nutrition, they fed the cereal to young rats, and another group of rats they fed a standard diet. So here, when we're making a comparison, our placebo, if you will, is not that they're not being fed, you have to feed the rats, but they were just given what they always had been given, and the other rats were given something new. So the rats were randomly assigned to diets and were housed in large racks of cages. But for whatever reason, it turned out that rats in the upper cages grew a little bit faster than rats in the bottom cages. So with that information, if the experiments put the rats fed with the new product at the top and those fed with the standard diet below, then the experiment's going to be biased. And the reason that is because it's hard for us to know if it was the food or if it was the cage location that actually determined the change in weight. So how could you fix that? Well, if you assign the rats to the cages at random, then you would have some rats in the upper cages with the new diet and some rats in the upper cages with the old diet, and then you would not have that source of bias. It's important for us to use a double-blind experiment because, as we talked about in Chapter 5, placebos simply work. We don't know why they work, but placebos can often cause a favorable outcome. So medical studies are going to take the special care to show that a new treatment is not just a placebo. So part of this whole equal treatment for all is to be sure that the placebo effect operates on all subjects. So here we see the study that I was talking about in Chapter 5 about balding men. So there was a study that found that 42% of balding men maintained or increased the amount of hair on their heads when they took a placebo. They were not receiving any treatment for their balding, but they did not lose any hair during this study. There was another study where 13 people who were known to be very sensitive to poison ivy, and they were told that the stuff being rubbed on one arm was poison ivy, but it was actually the placebo. In this study, all 13 broke out in a rash. Why the body broke out in a rash was surprising because there was no poison ivy given to any of these people in the study. Now, they also rubbed on the other arm what was actually poison ivy, but they were told that it was harmless. And what's interesting there is only 2 of them actually developed a rash. So these researchers were perplexed because the physical effect of poison ivy for these patients appeared to be somewhat psychological. So we have to be so careful of using a placebo because it's hard for us to know how powerful the human brain actually is. So with that in mind, we are often going to use this double-blind experiment where neither the subjects nor the people who work on them will know the treatment each subject is receiving, because doctors' expectations can change how they interact with a patient, and patients' expectations can change their outcomes. So whenever possible, anytime you have an experiment with human subjects, it really should be double blind.